Hello everyone, and I'll start this presentation. To assure the safety of structure, we need strain sensor. From the strain sensor, we can measure the length deformation. And nowadays, strain sensors are required in various fields, even big, small, curved, and large deformed structure. And I draw some diagram about 4 parameters which is related to weakness point of our nowadays strain sensors. If the strain sensor has these parameters, that will be used in various fields such as wearable device and high technology structure. And I compared representative strain sensors and 4 parameters. As you see, as an electrical sensor 4 gauge and vibrating wire exist, and as an optical sensor, FPG sensor exists, and 4 gauge sensor is not appropriate to these 4 parameters because material limitation, and vibrating wire also needs tightened wire, so that is not appropriate to large strain and flexibility. And FPG sensor also have a material limitation, so I searched some sensor, and that is a single wall carbon nanotubes strain sensor. In the paper, this sensor can be stretched until 35%, and that have 10% data. And that also have a problem because it is expensive. So to satisfy all 4 parameters, first we use the elastomer such as PDMS for large strain and flexibility. And to make any size or form, we thought of making method. We use these 3 materials, and we adapt the stencil method. And for price, we use cheap materials. So our electrical sensor has these 4 parameters. As an electrical sensor, our sensor has a resistive element which is composed of PDMS and exfoliated graphite. And resistive element is protected by electric insulator, which is composed and that is composed of PDMS. And this 1-axis sensor can be made multiple strain sensor, such as a 3-axis sensor. Our sensor have a very simple principle. If a strain sensor have length deformation, register will be changed. That is based on this very simple equation. So length is proportional to resistance. That is our fabrication process. In this process, I will skip the making PDMS process because that is well known. So, to make resistive element, we prepare the 3 materials such as nitric acid, potassium permanganate, and graphite. At the time, graphite has a stacked structure, and we have an experiment about graphite foam type size. And then we mix the 3 ingredients. At the time, intercalation agent is inserted to graphite structure, and we have an experiment about mixing ratio and mixing time. And we have an irradiation process. At the time, graphite structure is expanded by intercalation agent expansion. At the time, we have from this process we have an experiment about irradiation time. From these 4 experiments, we got the maximum expansion ratio of graphite. And then we cracked, in the sonication process, we cracked the graphite structure. And we have an experiment about sonication time. And for spray, we mix the 3 ingredients about hexane, PDMS, and exfoliated graphite. And we have an experiment because we have to see the characterization about conductivity and elasticity of a resistive element, and we sprayed and we dried and we covered this PDMS layer, and when the sensor is made, we had a tension test. We divided the experimental process as of two things. In the first experiment, the goal is getting small particle of exfoliated graphite. And in the second experiment, our goal is getting optimized resistive element for conductivity and elasticity, and then we will see the characterization of our sensor. In this experiment, we have some change in mixing ratio. As you see, maximum expansion ratio is shown in this point, and we got the maximum expansion ratio. The ratio is of graphite and potential permanganate nitric acid equal 1:1:2. And we have some change in mixing time. As you see, we have a maximum expansion ratio in 5-minute mixing time. And we have an experiment about graphite form, type, and size. And maximum expansion ratio is shown. Natural flake 40 micrometer graphite. And we have an experiment about irradiation time. And we got the maximum expansion ratio in 60-second irradiation time, because after the 60 seconds there's no meaning in expansion ratios. And then to get a small particle, we get a we have an experiment about sonication time from 1 to 6 hours. And as you see, the minimum diameter is get it in 6 hours sonication time. From this first experiment, we got the 5 factor, and then in the experiment 2, first to second experiment, we will have experiment. We had an experiment about mixing ratio to get a characterization about conductivity and elasticity of resistive element, and we will see the sensor's characterization. In this experiment, we have some change in mixing ratio. The weight percent is changed from 0 to 40 weight percent, and the difference of 25 weight percent and 40 weight percent is very little. That is 0.04 Siemens per centimeter. So we choose this 25 weight percent because we have to consider the elasticity. Before this conclusion, we have to show the relationship about mixing ratio and strain. However, 25 weight percent sensor shows enough strain until 50%. And from this result, we made these sensors, and as you see, and then we have a test about one axis sensor that is stretched until 50%, and as you see, it has high linear characterization between strain and normalized resistance. So we can see that strain is proportional to resistance. However, there are some problem in multiple strain sensor. Following this result, and 2-axis strain sensor, the resistance of 2-axis strain sensor didn't follow the Poisson's ratio. And 3-axis strain sensor also have a problem. If G-axis has a length deformation, X-axis and Y-axis will be influenced. So we need more study about this multiple strain sensor. During my presentation time, I mentioned our sensor's characterization, and our sensor can be stretched until 50% and have a flexibility, and it can be made any shape or any size by make a fabrication method, and it is very cheap. And I also mentioned about structure and principle and experiment and problems. So to adapt in real-time monitoring for structure health, we need more study about our sensor. Sorry for my poor English skills, and thank you. Do you have any question or comment?